I'll have all these notes I'm gonna send out to y'all. I did everything else. As soon as I have this done today, I'll send them all to you and you do your homework and you're done. The final exam's online. Take it whenever you're ready. You have 2 tries for that. If you need 3, tell me. I'll increase 1 more. But don't cheat. It's not gonna do you any good. Just do your best. All right, to begin with, okay, chapter 5, section 6 deals with definite integrals. Section 5 dealt with indefinite integrals. What's the difference between indefinite and definite integrals? Has a bound. And so what does it come up with? What are their final answers? Where are they? What kind of... Yes, exactly. Indefinite integrals have a formula with plus c, because you don't know what the constant is unless you have initial conditions. And definite integral gives you a number. What does that number represent? Very good. The area under the curve. Under the curve and the x-axis, or the curve and the y-axis. We can take it, we're going to look at both ways now today. You don't have to always take it vertically, you can take it horizontally. That's pretty cool though. So the first theorem we dealt with in this section is theorem 7, which is the one we'll be using all along. Substitution in definite integrals. If g prime it's actually g of x is continuous on a closed interval, and f is continuous on the range of that g of x, where g of x equals u, then we have this conversion. We have our bound from a to b. It's a composite function where the interior function, the derivative of it, is what's on the outside. Because if we have this scenario, then we can take the interior function, call it u. And then we can call the outside of the function the derivative. Since it's the derivative of g, it's the derivative of u. If we can do that, if we have this, a composite function with the interior function and the outside is the derivative of the interior function, then we can use substitution. But another thing happens. Not only do we change the g of x to u and g prime to du, we change the bounds of integration. We can either leave it in this format with the original question, or if we convert it to substitution to u du, then we also have to change the bounds. Whatever the lower bound is, plug it inside the interior function, and that gives you the lower bound. If you take the upper bound, plug it inside the function, the interior function, that becomes your upper bound. And then you can just take the integral of this function. It'll give you the same thing. We did that last time. I don't know if y'all remember. Let's look at what this means. That's true, because I think we probably moved too fast last time. Let me look for the examples here. Okay. Example 1. Evaluate this function. Remember what we just talked about. We have our bounds from a to b. We have f of g of x times g prime of x dx. That equals g of a, g of b, fu du. That's the conversion formula for substitution. So does our function satisfy this condition? What if we rewrote it? If we rewrote this equation, now does it match this? Yeah, we have an outer function, which is a square root. The inner function is g of x. So I'm saying here, g of x is x cubed plus 1. So what's g prime of x? What's the derivative of this one? 3x squared. Well, we have that too. 3x squared, and there's the dx. So this is f of g, and this is g prime of x dx. From A to B. This is A, this is B. So we're going to solve it this way, and then I'll show you, we'll solve it using the substitution method, leaving it in terms of u. So what we have to do here is we convert g of x to u, and g prime of x is du dx. Or I should just call it just du. We'll keep the same bounds for right now. So here, inside here, we have u. So it's the square root of u, and this is that. So it's du. So let's take the integral of this one. The square root of u becomes u to the power 1/2. What's the integral of u to the power 1/2? The integral is take the exponent, add 1, and divide by whatever that exponent is, going from -1 to 1. So I'll come back over here. So I have u to the power 3/2 over 3/2 from -1 to 1. Reciprocate the bottom. So far, so good. Now, because I haven't touched the bounds of integration, the a and b, I have to convert u back to what it used to be. What is u equal to? U is g of x. What is g of x? So we have 2/3 x cubed plus 1 to the power 3/2. Because u is equal to gx, and gx is this. So that's u. I have my outside coefficient. So now I take it from 1 to -1. So I have 1 cubed plus 1 to the power 3/2 minus -1 cubed plus 1 to the power 3/2. 1 cubed is 1. 1 plus 1 is 2 to the power 3/2. Negative 1 cubed is negative 1 plus 1. That goes to 0. So we have 2/3 out in front. This is a mixed number. So it's 2 to the power 1 times 2 to the power 1/2. Two times 2 is 4, square root of 2. And there's that answer. Questions? I see you all staring at it. Where did I lose you? You got it?
Yeah, I would think like, is it plus that this plus over because it's two are multiplied because that's what I want.
Right.
Yeah.
Okay, so that's starting off with the f of x function, converting to u and putting it back into original function. Now, let's do an example, the same example where we're going to stay as the substituted variable. We're going to stay as u. B. So we have from negative 1 to 1, 3x squared x cubed plus 1 dx. We can rewrite this, move things around so it's easier for us to see. That we have f of g of x, g prime of x dx. There's g prime of x. This is f of g of x. Let u be our g of x function, which is x cubed plus 1. And du is going to be 3x squared dx. So we have negative 1 to 1. We have the square root of u du. So that is my u. This is my du. Okay, that's the first thing I gotta change. Now I gotta change the bounds of integration. This one is going to be g at negative 1. This one is going to be g at 1. So here's our function g. When x is 1, 1 cubed plus 1 is 2. When x is negative 1, negative 1 cubed is negative 1 plus 1 is 0. So now we're going to go from 0 to 2 with that function. So now you see we changed the bounds of integration, we changed the function. So let's solve this one. So from 0 to 2, we have u to the power 1/2 du, which becomes 1/2 plus 1 over 1/2 plus 1 from 0 to 2. U 3/2 over 3/2 from 0 to 2. The bottom, it becomes 2/3. U to the 3/2. I'm just going step by step by step so you see everything. A lot of stuff you could skip. You can just go straight from here. Pretty much you can set this thing up here. So I'm just going through step by step. Now we put our bounds of integration. So here's our constant coefficient, put that in front. Now I just use the bounds. So I have 2 to the power 3/2 minus 0 to the power 3/2. That one's 0, so it doesn't matter. So 2 to the power 3/2, again, this is an improper fraction, so I could split it up. So 2 to the power 1 1/2 becomes 2 to the 1, 2 to the 1/2. So I have 2 times 2 to the 1/2 power. It's all divided by 3. 2 times 2 is 4. 2 to the 1/2 is square root of 2. Same thing. So it doesn't matter if we keep the bounds of integration or if we convert the whole thing to u, then we have to change the bounds of integration to be relative to the function g. And typically, the second method is a lot faster because you don't have to replace it and write down all that other stuff. It's much easier with u du. Yes.
Does this become y, right? How the bounds then y? Because when we plug it in, we're plugging in x and we're gonna get y. So bounds are now y.
Remember, we have two functions, a function within a function. So this is actually y. It's a composite function. I see what you're saying. What you're saying is y is equal to g of x, right? But what is f of g of x? That's actually what y is. Remember, we're dealing with, you have to have a composite function. So this whole thing is your real function. It's just a function within a function. So this function is within the square root function. So no, what you're saying, don't look at it x as x and y anymore, because now we're dealing with composite functions. If you try to do that, then you could look at y1 and y2. Y2 is the whole equation, f of x, g of x. So what you really have is f of 2, f of 1 of x. That's a composite function. But only works when you have composite, or only works when you could have du, u du comparison. We just did.
Like like on the graph. Like on the graph.
Okay, oh, yeah, okay, that's what you're saying. So the first one we had, well, so here's our function. The graph of this one is a cosine function. So the traditional cosine function looks like this. It's bounded by 1, -1. But we're only looking at for this area here from zero. We're only looking for this area. So that's traditional cosine, but our angle is 3 times. So what happens here is our graph, it's a horizontal stretch by 3. So instead of 3 pi over 2, now our graph will look like then 3 pi. So your graph will look like this. Okay. So your amplitude has changed. Not amplitude, but your period changed. Now, what we're doing here, we have our u was, I need to have a 3. Our u is 3x. The du is 3. Do we have a 3 on the outside? No. So I put a 3. Well, actually, I put it right here because it's actually 3u, 3dx. Since I had to put a 3 there, I got to put a 1/3 out in front because they need to cancel. They need to still remain the same as the original equation. So now, this is A and this is B. Our function is cosine u du. Our bounds of integration are now going to change. When it goes from 3 times 0 is 0. And this one, 3 times pi over 2 is 3 pi over 2. So that's what it looks like. That's how our graph is going to change. Our original function converted to this one. So it'll be some of a horizontal stretch or constriction, or it may even be a vertical. But we also have a 1/3 out here. So our graph is a lot less. It's shrunk because of the 1/3 that goes out in front. So whenever you change the bounds, you change it. It's just that the area is going to be the same. This area and this area are going to be the same. Because it's shorter, it's 1/3 shorter, it's also 3 times longer. So if we look at just rectangles, if we took a box of 1 and 1 and we shrunk it to 1/3, but instead of 1, it's now 3, it's going to be the same area inside there. Because 3 times 1, 3 times 1/3 is 1. 1 times 1 is 1. So the area is the same. It just changes. That's how come you have to change the bounds of integration whenever you change from f of x gx to u. Good question. That's a very good question. The answer is going to stay the same. It's just the equation looks different because you change the bounds of integration. Okay, what is an odd function? What is an even function from algebra? Well, let's look at even. A function, f of x. So if I graph this one when X is positive, Y is gonna be positive. So X, F of X. An even function is if I change the X to a negative X and it still gives me the same value. That's an even function. Even functions are symmetric about the y-axis. Odd functions. If I change X to negative X, it changes the sign of the value. You'll have the same numbers, but the sign's going to change. Let's look at some examples of this. Let's try 3x squared. F of X equals 3x squared. Is that an odd or an even function? Why? You have to do it with test. So if I put in 2 inside here, I got 3 times 2 squared. 3 times 4 is 12. Now, if I put a negative 2 inside there, 3 times negative 2 squared is still 3 times 4 is still 12. I get the same number, even though I changed the sign of the input. That's an even function. Same thing here. So let's try it. Let's plug in 2 and then put in a negative 2. If I change the sign of X, 2 cubed is 2 or 3 times 8, which is 24. 3 times negative 2 cubed is 3 times negative 8, which is negative 24. I get the same number, except the signs have changed. That's an odd function. That's how you determine if it's an odd. So odd functions are reflective about the origin. Oh, excuse me. And even functions are reflective about the y-axis. Why does that matter? Because remember, even functions, no matter what side of the vertical axis you're at, it'll always give you the same sign. So if a function is even, so if I had a function that looks like this, and it goes to A, that means it has to have a symmetrical side on the other side. So if I go from negative A to A, remember, this is my function. From negative A to A, I could do it another way. Since I know they're symmetrical, what I can do there is I can just take it from 0 to A and double it. Because these are both going to be the same, A1, A2. That's why I double it. Because it's symmetric about the y-axis, they're equal sides both sides. That's for even functions. Reflexive and symmetric about the y-axis. So A1 equals A2, which is why, that's why we do 2 times A1 equals the true area. All right. Now, if we have a function that's odd, remember, it's got to be symmetric about the origin. The origin. So what does that mean? What that means is they're both going to have the same area, except one of them is going to be negative because it's below the x-axis. So this is from negative A to positive A. If we took it this way, our area would be 0. So if you ever just take what's given and take the integral of it and it gives you 0, that's what it tells you. So what do you got to do? Find any x-intercepts in the closed interval AB. So we'll call the x-intercepts, we'll call those C's. What we have here, we have the first point is A, the second point is B, and where it crosses the x-axis, we call that point C. Now integrate on the subintervals AC and CB. So what negative A to A would give you would be negative A to 0 plus 0 to A. Okay, not done yet. This is still going to give us 0 because now when we do this, we can see exactly which part is below the x-axis. When you do the integration, if one part gives you a negative answer, negative area, we know that that's below the x-axis. And the other one has to be the same value, but positive. So there's 2 ways to fix it. One way is take the absolute value. of the areas. Or reverse the bounds of the negative area. So in this first one, we look at our graph, we see that from negative A to C, from A to 0, that is negative area. So we can fix that by changing our bounds. Instead of from negative A to 0, go from 0 to negative A. That'll give you a positive answer now. And then leave the other one alone. So it's 0 to negative A, 0 to A. That's how you do it. So from 0 to negative A. So whenever, because you can't really, you cannot have negative areas because an area is a positive value. So our next example. Yeah. We can use we have our integral from -2 to 2, x to the 4th minus 4x squared plus 6 dx. So if I just gave you this question, what would you do first? If this was a test question, and I just gave it to you and asked you to find the area of this, you just take the integral of these and see what you get. Okay, so let's see what that does. So we have from -2 to 2, because these are all addition and subtraction, we can separate them. We could treat them all separately. That's one of our properties. If you have an addition or subtraction, you can separate those individually. So what's the integral of the first one? Take your power, add 1. Whatever you do there, you gotta do to the bottom. From -2 to 2. That's a constant multiple, so it can go out in front. So the integral of x squared becomes x squared plus 1 from -2 to 2. And what's the integral of 1? X. From -2 to 2. So we have x to the 5th over 5 from -2 to 2. 4x3 over 3 from -2 to 2. And then 6x from -2 to 2. The first one, start at the top. So it's put 2 in place of X and subtract the bottom one at -2. Do the same for the middle one. So we have 4, 2 cubed over 3 minus 4 -2 cubed over 3. 6 times 2 minus 6 times -2. Two to the fifth is what? -32. -2 to the fifth. -32 over 5. Two cubed is 8. -8. 12 minus -12. So we have 32 over 5 plus 32 over 5. 4 times 8. 32 over 3 plus 32 over 3. 12 plus 12. What do you see here? 2 times 32 over 5. 2 times 32 over 3. 2 times 12. So what we see here is we didn't have to go from -2 to 2. We could just have gone from 0 to 2 because it's doubled. From -2 to 0 will give us the same answer. So we could have saved ourselves a whole bunch of time there, but what do we notice about the original equation? Well, it depends, yeah, but what we're looking for here is, well, what can you tell about the function? Because these are symmetric, that's a good indication, so we have to check something. Is this an odd or even function? Why? Because it has a constant there. It can only be even. Evens can be if all the exponents are even only, or if you have even exponents and a constant. Then this function is even. If we would have noticed that to be from the beginning, we could have changed this earlier. We could have changed it to that. Because from -2 to 0 is the same from 0 to 2. So I'll just take half of it. So that's right. Before you do anything, see if it's an odd or even function. If it's an even function, then whatever your bounds are, split that in half because it has to be equal in both halves. Let's look at another one. What do you know about this one? So what does that tell us? Yeah, you're jumping to the answer, but what do we have to do to set it up? What does it tell us? What's gonna happen? Before that? The area of this integral is gonna give us 0. Because if we tried it, we have 3x cubed plus x, which becomes 3x to the 4th over 4, x squared over 2. Three to the 2/4 over 4 plus 2 squared over 2 minus -2 to the 4th over 4 plus -2 squared over 2. This is at +2 and this is at -2. Three times 16 over 4, 4 over 2. Those cancel, so we have 12 plus 2 minus 12 plus 2. You would take the integral, you see that it equals 0, which tells us automatically that it's symmetrical and it's an odd function. And we can look at it, yes, all the powers are odd, so it's an odd function. So what do we do there? So first step, find the x-intercepts. Take your function, set it equal to 0, and solve for x. So it's only 2 terms. We can factor out an x. Set them equal to 0. So there's our one intercept. And that one can't be, it's imaginary. So the only x-intercept we have is at 0. And fortunately, 0 is within our domain, our bounds of integration. So what we have to do is we're going to have to take our equation from 2 to 0 and 0 to 2. And change the bounds of integration, because we know that looking at the equation, one of them is negative. Since it's odd, the odd negative side is negative, positive side is positive. So we change the bounds of integration, or we can take the absolute values of both of these and then worry about it later. So that's what you're looking at here. So far, so good. Now comes the fun part. So far, we've been only dealing with equations with respect to only one axis or one equation. Well, actually, before we do anything, let's look at this example. Let's try square root of x. On that domain. With respect to dy. What does that mean? What we'd normally look at this thing, our function would look like this from 0 to 4. When x is 4, y equals 2. And we'd look for this area. Typically, we have vertical slices. But now what I want is I want to know with respect to the y-axis, how would it look like this? So this is y equals square root of x. We have to convert this to dy. So first off, we have to change this one. And we have to change this to be a function of dy. So what is this going to be? Because that's what the function equals. Solve for x. Now, let's look at the bounds of integration. These used to be my x values. So at what point does y squared equal 0? Square root both sides. So it equals 0. Where is our function y squared? Where does it equal 4? Square root both sides, you get 2. So when you change from dx to dy, you have to change the bounds of integration with respect to our new formula. These are the x values. What do they correspond to? So now we got to look at this equation. What does this graph look like? It's a parabola, but we only take the positive sides of it. And we're only going from 0 to 2, so we're looking for this area. Because remember, the integral finds the area under the curve to the axis. So if it was vertical, it's going from the function to the x-axis. But since we're horizontal, we're going from the function to the y-axis. So integrate that, you get y cubed over 3 from 0 to 2. So it's 2 cubed over 3 minus 0 is 2 cubed over 3, which is 8 over 3. So whenever you change the direction of integration, you also have to change not only the the x to y, the dx to dy, but you have to change the bounds of integration.
Also subtract the rectangle,
The what?
like when you get the bound from the x-axis, then just subtract the rectangle,
What rectangle?
like from 2 to 4. I guess like the blank space,
But what is that? What would you subtract?
your initial answer.
I didn't have it. Remember, this is if we didn't know this. I'm giving you this. I'm asking you to find it with respect to this. We never found this part yet. But then again, the next thing you do is what would you subtract from what? It's not a rectangle, but it's a curve. Rectangles are triangles are straight edges. What you would do, you're right, because if you extend that logic, we just found this area here. That is 8/3. We can pretty much try to guesstimate what this is because we know the total area is 4 times 2 is 8 minus 8/3. The remainder will give you this. But then again, that's not what we're looking for. We didn't want that in the first place. We just wanted this area here. So our answer would be 24/3 minus 8/3 is 16/3, which is 5 1/3. So there's another way. Okay. What if we're still the same picture? Let's say this time I want to know what this area is. How would you do that? I want to do it. Yeah. I want you to solve it using it with respect to y. Okay, I make the box. Now, what's that?
Remember, take the whole area, like, take the width times the length. And that's
That's 8. Okay.
the minus the area of y, with respect to y, and that would find the other area.
So you're saying find this and then subtract this. In essence, yes, but you put it all together. But since we're looking at these slivers here, we only want these. We don't want those. Remember, the concept is this. The concept of an integral is from the function to the axis of whatever you're integrating by. What if we had two functions from A to B? I want to know this area. Remember, it's a curve. So we couldn't use that, the square thing that you were just predicting. One more time? Why? Very good. Very good. Yeah, that's exactly right. Because f, the integral of f is from this to here. The integral of g is from here to there. If I take f minus g, I'm taking this whole area minus this area, which leaves the middle part. Exactly. So whenever you have two integrals or two functions, and you find the area between them, always take the higher function minus the lower function. So f of x has to be higher than g of x. Let me put an example here. There's one function. And the second function is that. Okay, let me read the said find the area of the region bounded above by the curve. So this is the above one. This is f of x. Below, this is my g of x. On the left, by x equals 0, and on the right, by x equals 1. This is the way the questions will be given to you. The first thing that would help us, you need to, once you do the mathematics. But since it labeled already which one's higher, which one's f of x, which one's g of x, and our bounds are from 0 to 1. So whatever our functions are, I'm looking at it in this area. Okay, if they didn't tell us which one's higher or lower, how would you find out? Remember that f of x is always bigger than g of x. How would you find out which one's the f of x? We know the bound, the domain is from 0 to 1. What would you do? How would you graph it? Yeah, so you wouldn't graph it. Let's go somewhere else now instead of that. Yeah, which number would you put in there? 1/2, yeah. Put a number in there and see which function gives you a higher number. That's your taller. Yeah, exactly. That's exactly what you do. You don't have to graph it since we know what the bounds are and everything. So we know our bounds of integration are from 0 to 1. F of x minus g of x dx. That's what we're looking for. So we have 2e to the negative x plus x minus e to the x over 2. Dx. What would you do next? Yeah, since they're all addition subtraction, we could do them all individually. Or you can do it all at one time. Yeah. If you want to save time, you just treat all three of these individually. So the integral of e to the power negative x. Okay, so if you're saying the integral is e to the power negative x, that means, remember, this is the derivative. What's the derivative of this? So does this have a negative? So it needs a negative. So the first one is negative two e to the power x from 0 to 1. Because whatever you think your integral is, take the derivative of it, see if you end up with what you have here. So if I had, well, the 2 is a constant, so it goes out in front. So the negative e to the negative x, the derivative of this would be e to the power negative x with a 2 on front. So that's what you'd have to have a negative sign. The next one, the integral of x. Yeah, x squared over 2. And you have a constant, which is 1/2. So the integral of e to the x is e to the x over 2. Now we plug in 1, then subtract the 0. So we have negative 2 e to the negative 1 minus negative 2 e to the 0. 1 squared over 2 minus 0 squared over 2. E to the 1 over 2 minus e to the 0 over 2. Just do the algebra part. It's going to be a plus because that negative sign. Don't move on until you know exactly how I got from here to here. Don't just copy it down. If you don't see it automatically, then ask me. Because I'm looking at your faces and you're trying to figure out what it is. All I did in this step, I plug in 1. So negative 2 e to the negative 1 minus negative 2 e to the 0 plus 1 squared over 2 minus 0 squared over 2 e to the 1 over 2 e to the 0 over 2. E to the 0 is 1. E to the 0 is 1. So that becomes a +2. 1/2. E to the first is E over 2, it's minus, and then the negative times negative makes it a positive. So the answer is 1/2 plus 1/2 is a 1 plus 2 is 3. Whatever that is, was E is a constant. Any questions? Well, whatever this is, yeah, because that's what we start off with. Here's this. That's why you always have a trail of what's going on. So this is the area between those two curves from 0 to 1. Find the area between those two. So what's the first thing you're gonna do? Okay, yeah, which one's F, which one's G? Well, how do you know which number to put in there? Do we know what bounds of integration we're gonna be using? How do we find it? To find the bounds, set y1 equals to y2 and solve. Because at the x values that come out here, that's where the two lines intersect. And that's the only place we can figure out where the two lines are going to be integrable. So we have 2 minus x squared equals -x. Well, algebraically, we can see which one's the higher of the one, which is the smaller one. Because if this one's an easy one to graph because it's a quadratic equation, it's pointed down, it's lifted up 2 spaces. This one is -x. So we're gonna have 2 points of intersection. This is the way we'll find them. So we'll move everything over since we have a negative here. So we have 0 equals x squared minus x minus 2. I have opposite signs. What times what is 2 when you subtract them, you get 1? 2 and 1. The bigger number has to be negative. And so my x, where they intercept, are at -1 and +2. So our bounds of integration so we know that this is our F and this is our G. So we have 2 minus x squared minus negative x dx. Because that's our f minus g. Is this function odd, even, or neither? It's what? It's neither, because you have an even exponent, you have an odd exponent, so it's neither. So we can't use that shortcut we did a long time ago. So integrate all three of these separately. The integral of 2 is what? 2x. The integral of x squared? X3 over 3. Because remember, you add 1. And the integral of x is x squared over 2. If you don't see that, then do them all individually. You'll get the same answer. So now putting 2 in its place. So we have 2 times 2 minus 2 cubed over 3. 2 squared over 2 minus 2 times negative 1. Negative 1 cubed over 3. Negative 1 squared over 2. Save your next. This is all algebra part. This is stuff you should be able to do yourself. Don't just copy down what I'm putting down. If you don't see why I'm putting everything here, then you should ask me questions instead of just copying. Work it out. Eight over 3 plus 4 over 2 minus 2 plus 1/3 plus 1/2. So that's 2. So we have 6 minus 8/3. So I'll get a common denominator for the whole thing. It's going to be 6. So I multiply everybody by 6 over 6. No, this is 6 over 6. This one is 2 over 2, so it's 16 over 6. This one is 6 over 6, so it's negative 12 over 6. 2/2. And this is 3/3. (20/6). -10, -7/6. So 20/6 plus 7/6. 27/6. They both have a 3 in common. 9/2. Again, it's the algebra part that makes most of y'all, everybody, that's when mistakes gonna happen. All right. Find the area of the region in quadrant 1 bounded above by y equals radical x and below by y equals x minus 2. Try to work it out yourself. Don't read ahead. This is all that's given to you. It's find the area of this graph in the first quadrant, bounded above by this function and below by the other one. So what's the first thing you gotta do? Well, there are two things we can do. We could set them equal to each other, see where they intersect. Okay, so I set the first one, so y1 equals y2. So square root of x equals x minus 2. Now solve for x. What do you have to do first? You're solving for x. What do you have to get rid of? Get rid of the radical. You can't solve inside radical, so we have to square both sides. Set it equal to 0. I subtracted x from both sides. Yeah, this is the algebra part that you have to know. So we factor both the same signs, they're both minuses. What times what is 4? When you add them, you get 5, you get 4 and 1. So the points of intersection, or I say the intercepts, are at 4 and 1. But what's the problem with that? If we drew the graph of this thing, the first one, square root of x, looks like this. That's the square root of x. The second one, it's a linear equation, y-intercept at -2 and up 1 over 1. And they intersect at 4. Because that's what this is telling us. We said the two equations equal to each other. If we would continue this, it would, remember the top looks like this. It would also have another intercept here at 1. But we're only taking the first quadrant of it. Because that's what y equals square root of x look like. It's half a parabola. We want to know this area. So do you see a problem? Because if we just do the integral of f minus g, then we'll have this area down here also, which we don't want. We only want quadrant 1. So we have to take 2 integrals here. What's that point there? Remember, this one is x minus 2. When does x minus 2 equal 0? When x equals 2. So this is at 2. So this first area and this is the second area. The first area is just our function from 0 to 2. So the area of our first one is from 0 to 2 of our f of x function. Because the g of x doesn't do anything here between 0 and 2. Then we're going to add from 2 to 4. That's when we do the f of x minus g of x. So this is, again, the second part. This is where we have the g of x contributing to this area here. That's why I take f of x minus g of x and just have this area there. So it helps if you draw a picture to give you what you need. The rest of it's just plug and play now. From 0 to 2, square root of x dx. From 2 to 4, square root of x minus 2 dx. Just plug them in there. So x to the power 1/2 dx from 0 to 2. We have x to the power 1/2, and this negative makes it negative x, positive 2. Now we just take it like we normally would. The rest should be straightforwardly easy. Okay, so what are you staring at? It'll save us a lot of time if you ask me what you're looking at. No, all I did was just, I'm just setting up my equation. I haven't done the integral yet. That's why you still see those there. All I'm doing is setting it up is the most important part. If you set it up incorrectly, there's no way you get the right answer. Now, the integral of the first one is 1/2 plus 1 over 1/2 plus 1 from 0 to 2. One half plus 1 over 1/2 plus 1 minus x. This is a 1 already. 1 plus 1 over 1 plus 1. 2x to the first. From 2 to 4. So we have x 3/2 over 3/2. X 3/2 over 3/2 minus x squared over 2. 2x to the bottom. So we have 2 over 3 x 3/2. 2 over 3 x to the 3/2. X squared over 2. Now I go ahead and plug them in there. Remember, this improper fractions, I can split them up into a mixed number. We have 2/3. So it's 2 times square root of 2 minus 0. Four square root of 4 minus 2 square root of 2. Four squared over 2 minus 2 squared over 2. 2 times 4 minus 2 times 2. Two, so 8. minus 2 radical 2. That's 16, that's 4, so it's 8 minus 2. 8 minus 4. Six plus 4. Those cancel. 16 over 3 minus 6 over 3 equals 10 over 3. Yeah, that sheet I gave you, don't rely too much on it because it skips a lot of steps. Yeah, those, don't rely too much on those because it skips a lot of steps. If you try to follow that and not listen to me, you're going to be getting yourself confused. That's why I really should start giving those things at the end of class instead of beginning of class because it distracts too many people. All right, let's do the same equation this time, but taking it with respect to y. So we had y. No, because the other one we have to take it, we have to take it that way because we're doing with respect to x. It's all vertical. Now we're gonna look at, we'll get the same answer, but we can take it horizontally. Because we'll have the same picture. We'll have the same picture. This is f of x. And this is g of x. Now we're going to take it horizontally. Which means this is where it gets difficult now. Because this one is square root of x. This one is x minus 2. Yeah, this part's easy. Now we got to figure out how to convert them to the y variables. So now we're going to do f of y, g of y, minus g of y, or whatever that relationship is. Because what changes now? Since we're doing it horizontally, we're no longer doing f minus g, because horizontally, this is the bigger function. So we're going to do g minus f now. Flip it over this way. Which one's higher? The g function. Yeah, when we have the x-axis on the bottom, the f function's higher than g of x. But if we turn it sideways, whatever axis we're going to look at with respect to, put that on the bottom. Now we see that g is bigger than f. And we have to figure out from where to where. So when we went from 0 to 4 the first time, what is this one going to? When x is 4, what's y? Two. Should put it this way. 2, right. So now our function is going from 0 to 2, g of y minus f of y dy. So this equals y equals square root of x. So what do we have to do? We need to have functions with respect to y. So we have to solve for x. These are, the original function we did last question was y equals f of x. Now we're doing x equals f of y. So x is equal to y squared. X is equal to y plus 2. Those are my two functions. We're going from 0 to 2. Y plus 2 minus y squared dy. So go ahead and integrate that by pieces. You see, it's a lot easier if we do it this way. The integral of y is y squared over 2. Integral of 2 is 2y. Integral of y squared is y cubed over 3. Get a common denominator, which is going to be 6. 12 over 6. 24 over 1. 16 over 6. .36 minus 16 over 6. 20/6. They both have a 2 in common. And there's our answer. Well, educatum. What was to be taught? End of the semester. We did that already. That's example 7. That's okay. It's not the first time. I can tell because you can tell your mind is always deep in thought during class. So, but yeah, that's the end of the semester. We can now have next week free to do whatever you need to catch up everything and then take the final exam when you're ready. I'll be here next week sitting down doing my work if you have any questions. But again, I'm gonna send you all the videos today. And if you're interested in Cal 2, I'm gonna ask to increase the number and I'll send all the videos and notes out for Cal 2 today. Thank you all so very much. I really, really, really enjoyed it. And I'm so proud of you all for showing up here every day, even though you could have been lazy and done it online. And that tells me that you guys are devout students and you want to learn. So definitely that puts you on a list. Is if you ever need a recommendation letter or anything, just tell me because you guys deserve it. Because this is what I see. Because look at, we have 25 students enrolled in this class. Nobody dropped out.
Mhm.
We have 20 people doing it online or at home. So yeah, there are constant people. We always have 2 or 3 people always doing it online. They're participating in the backgrounds, them also. But the rest of the people who are waiting for the videos are doing other ways. Those people, again, it's not. So, but you guys for sure. So, okay, right. That's the end of the week. That's the end of the semester for you guys. Again, final exam. If you need, you have 2 tries at it. If you need a 3rd try, tell me and I'll increase the number to 3. Thank you all for a great semester.